So another way to do this question is by completing the square, and this is a method that comes in handy in other questions as well. So what I'm going to do is to eliminate a and replace that here. So 4x minus 4y minus 4z is 3 plus 4y squared plus 4z squared. Now I'm going to move all these terms to one side and equate it to 0. So 4x squared minus 4x plus 4y squared plus 4y. And this would be plus 3 equal to 0. So I'm going to try to complete this square by factoring 4. So x squared minus x. So this would be x minus half square. But then you'll get this constant, so I have to subtract 1/4. And you can check. If you expand this, that will be exactly that. So this piece is going to become 4 times x minus half square minus 1. Because now I'm distributing that 4. We're going to use the same approach here, and here you will end up with y plus half square instead of x minus half, because this is a plus. And then we'll have a minus 1 again. And we do the same thing with the z term. Plus half square minus 1 plus 3 equal to 0. Now you'll notice that these all drop out, and we end up with this equation. I mixed the order. It doesn't matter. So we have only square terms here, which are always going to be greater than or equal to 0. Positive. So for this equation to hold true, the only way that will happen when each of these pieces is equal to 0. That means x has to be half, z has to be minus half, and y has to be minus half. So that's the constraint. And with that, we can figure out what a is. A plus 3. All I'm doing is substituting x, half minus minus half, so that would be plus half, and then plus half. So that becomes 4. 6, so that means a is 6 minus 3 is 3. So this is a lot easier than what I did originally, but that's kind of what came to my mind, and that's what's going to happen in the exam, where you have one method that comes and maybe you're able to complete the question that way, but this is a hard question. But yeah, this is again a standard method used in a lot of these questions to add this constraint by coming up with these squares. And that way, the only way you'll get a solution is when each of these terms is 0. So that's another way of approaching this question.